Welcome to the Pacey Performance Podcast. Today, I'm speaking with Senior Strength and Conditioning Coach at the English Institute of Sport, Ben Rosenblatt. This episode of the Pacey Performance Podcast is sponsored by Valid Performance, makers of the NordBoard. So if you haven't heard of the NordBoard already, don't worry, I'll explain, it's really simple. So the NordBoard is a fast and accurate way to measure hamstring strength. So as practitioners, we can do very little about athlete age and previous hamstring injury. But what we can do something about is our athlete's eccentric strength, and that's where the NordBoard comes into play. It isn't going to get your athlete's hamstrings bulletproof, but what it is going to do is going to give you the right information so you, the practitioner, can make the right decision at the right time. With the NordBoard now available and being bought by the likes of David Joyce at the GWS Giants in the AFL, if you're interested in finding out more information, you can email info@valdperformance.com or visit valdperformance.com. This episode of the Pacey Performance Podcast is sponsored by Train with Push, creators of the Push Band. So the Push Band is the first scientifically validated wearable device to provide objective insights into your performance in the gym. So using accelerometers and a gyroscope, the Push Band is able to use bar speed to regulate load and volume based on your ability in the gym on any given day. So you can use the push band to quickly establish 1 RMs with submaximal load so you can plan with confidence. So the push band portal also allows you to create programs before entering the gym to make change on the fly depending on how you are performing on that given day. So you can customize everything from target velocity ranges to differentiating velocities for warm-up and creating working sets and supersets for yourself or your athletes. So if you do want to know more about Train with Push and the Push Band, get yourself over to trainwithpush.com. They also have got a great blog, so you can catch up with some guest bloggers such as Mladen Ivanovic and Dan Baker. So be sure to check them out at trainwithpush.com. Thanks for tuning in to episode 70 of the Pacey Performance Podcast. So just before we get over into the chat with Ben, just want to remind you of episode 3 of the Pacey Performance webinar series with Matt Jordan. So if you are interested in hearing Matt present on monitoring athletes, detecting asymmetries and fatigue, you can get over to paceyperformance.co.uk/Matt. That's MATT. So all the details are on there. It's going to go live on the 21st of February at 7 p.m. GMT. So if you're interested, get over to that link now. So I'm not going to introduce Ben at all. The episode is great. You'll absolutely love it. And let me know what you think. Okay, thanks for tuning in to the Pacey Performance Podcast. Today we've got Ben Rosenblatt on the phone, who is the Senior S&C Coach for GB Hockey. So just before I give Ben a little intro, just want to thank him for his time on a Sunday evening to speak to me. So welcome to the podcast, Ben.
Thanks very much, Rob, and it's a real pleasure to talk to you. I'm a really big fan of the work you're doing, and it's an honour to be invited with the sort of high level of the guests that you've had on. It's very humbling, so thank you for inviting me.
Absolute pleasure, mate. So obviously, I saw Ben present with Jonas a couple of months ago, well, just before Christmas. So after that, I don't think I'd seen you present before or speak before. So after that, I had to get you on the podcast. So do you just want to get anyone that doesn't know, just to give them a bit of an intro into your background, your education, and what you're currently doing?
My role at the moment is the Senior Strength and Conditioning Coach with the GB Women's Hockey team. I work as part of the physical preparation team for GB Hockey. Andy Hudson runs the department, and he leads the program for the men. Tom Drowley is the S&C coach who works across both programs in a development program. And we've got 2 work placement students. One is an S&C work placement student who's completing a PhD in biomechanics and motor control. His name's Tom Ruska. And another one is completing their final year of their physiology, their sports science undergraduate. Her name's Megan Moran, and she works as our physiology work placement student on industrial placement. So that's our kind of team. I also work with the some of the Great Britain judo fighters, and I've been working with them for about 7 or 8 years now. And we continue to work towards Rio for those guys. I've got a small consultancy where I kind of go and get to talk to lots of different people and kind of learn from them and help them solve performance problems. And I recently completed my PhD in biomechanics and strength and conditioning. I was particularly interested in specificity and looking at how exercises transfer into performance and basically what the biomechanical basis of exercise selection should be. So that's my kind of real research interest area. And before that, I worked in the BOA's intensive rehabilitation unit. That was a residential rehab centre. And that was established for residential rehab. And the idea is to accelerate the rehab of injured Olympic athletes. That was an incredible experience. And prior to that, I worked in professional football.
So how was the how does football compare to the rest of the CV?
In what way? In what way?
Yeah, just the kind of environment, the culture, the size of the team, the quality of the team. Not as in the playing team. I mean, obviously the staffing.
Well, yeah, it's really interesting actually. I think that like every single team that I've worked with and every sport that I've worked with have got their own sort of microculture, or they've got their own identity, and every sport in particular. And I'm sure that people who've I always remember I did some work with some gymnasts, and I was having a chat with the coach, and the coach said to me, I don't think you understand, Ben, this is gymnastics, and gymnastics, the gymnast bodies, they adapt differently to all the other different types of athletes that you work with. And of course we know that that's not to be true, but that's kind of what every sport thinks and every different team thinks, and you can't go into one sport and you can't go into football. When I worked in football, before that I worked with the British Olympic Association, and again in the build up to Beijing, and I said, well, this is what we did with the with some of the rowing team. They go, hey, listen, we're not rowers, we're footballers. And and so I think it's really important. So every single team and every single sport has got their microculture, and it's like their tribe. And when you start working with them, you spend the first chunk of time generally just trying to get accepted into the tribe, and then you can start to try and work with the tribe and contribute and become part of the tribe as well. So those are kind of, I think those are, I suppose you asked what the kind of differences were, those are the similarities, and that's the kind of way I approach it. Really, become part of the tribe first, and then it's all the same,
Yeah, of course. So it interests me that when you see people's kind of CVs on LinkedIn, when you're stalking them, maybe that's just me, but you see the CVs, and you see some guys who have been in football for 20 years, or people like yourself who have maybe jumped around and experienced different sports. But how do you go about making that transition from, say, football to judo? Having, actually, you've mentioned the similarities, but with the differences as well. So how do you become part of that tribe when you enter that environment?
Well, I think that the important thing is listening. Like the first thing I always try and do when I work with new people, and the people that I continue to work with on long term as well, like really listen to them. And so what are you actually trying to achieve? And you've got to have sort of good self-awareness around your skills, your expertise, the things that you know, the things that you can deliver, and you've got to try and get a real thorough and complete understanding of the scenario, the situations, or the problems that the athletes and the coaches that you're going to work with are facing. So, for me, the most important thing you can do is do a good deal of watching and listening, and really trying to understand what it is that these guys are trying to achieve and trying to do, the constraints that are placed on them. And then you've got an opportunity to sort of match that up with what you've got a picture in your head, and then go, okay, here's how I think that we can impact. And then another thing is actually having a common language. And a lot of the time it's bending your language to suit the language of the people that you're working with. to make sure, because it's not about people understanding you, it's about you being understood by people, if that makes sense.
No, absolutely.
Yes, you said earlier that I could, at some point in time, I could scrub stuff out, so maybe we'll go and do that. So for me, the critical things are understanding precisely what your skill sets are, precisely what impact you can have is, and the skills of the team around you as well, and knowing the limitations and the knowledge, the limitations of you and your knowledge and your skills, and then is this an area I need to grow? And then having a really complete understanding of what it is that the people you're working with are trying to achieve and what limits them, and what they can leverage off. So those are always the conversations I continue to have with the coaches that I continue to work with as well. How is this fighter going to win an Olympic medal? How is our team going to win the Olympic Games? What are our threats to doing that? What do we need to leverage off? And talk broadly, nothing to do with physical preparation or sports science, just what is it that's important? And if you can work out what's important, then you can work out where you're going to impact.
I mean, you mentioned there about what's the question, and that just reminded me of something we spoke about before, just about GPS.
Yeah.
And obviously saw you present just before Christmas, and there seemed a real connect between you and the coach with regards to programming and things. And obviously that's why I've heard that you're doing really good stuff with the GPS. So how do you foster that relationship with the coach? And secondly, how has that been able to you to really use GPS to inform and program off the back of it?
Yeah, for sure. I'll probably, if I could talk about the GPS stuff to start with, because I can certainly talk through the approach that we've taken with that and how the place we're up to now. And then maybe talk about the approach to take to building relationships.
Absolutely.
It's funny actually building relationships when do I have an approach to building relationships? It kind of feels a bit subversive. It's almost like when people have read the that chat up book, The Game, and they go, right, now I'm going out and going to meet a girl. It's kind of a bit like, oh, come on, that's cheating.
Yeah.
So I suppose the GPS, the GPS side of it. When I started to work with the hockey team, the first conversation I had at the time was with the guy who was head coach at the time, was a guy called Jason Lee, and we were looking at the team, and he was looking about where he wanted to go. And it's exactly the same questions. It's like, what do you need me for? What am I here for? What does physical preparation mean to you? What's the important parts of my role? What do you want me to deliver on? And he said, look, it's really crucially that I need to develop this team. Like, this has been one of the fittest teams in the world. Dave Hamilton worked with the group beforehand. It's just been one of the fittest, most athletic teams in the world. The rest of the world are catching up from that perspective. And if we want to do well, we need to develop as a hockey team. So therefore, I need to spend as much time on the pitch with them as possible. So your job is to make sure the players can turn out for every training session and to try and find a way of developing them physically through hockey training. So we had these sort of 16 GPS units, which were the old GP Sport ones, and they were used intermittently throughout different tournaments to try and understand the physical demand of international hockey, because no one really knew that from a scientific perspective. And then we kind of had these units, said, right, well, let's bang them on for training every single day. And then at least what we can do is try and gain an understanding of the physical demand of the different types of drills that the coaches employ. And then we can interpret that into the language that we know as sports scientists and strength and conditioning coaches, which is sort of general stress and sort of physiological load. And then we can help inform the coaches, or give them a framework for making training decisions off. So we can say to them, this is a high loading day, or we feel that throughout this period of time, for example, we'd really like to overload the cardiovascular system for these couple of weeks. Therefore, based on the data captured and collected, we know that these type of drills will help deliver that, or these constraints on the drills will help deliver that. So initially, what I looked at, so I suppose if I talk about the drill analysis first, and then the programming and stuff, and then I can nut into some of the GPS detail. What we did with the sort of drill analysis to start with was, exactly like I said, we looked at all different drill categorised it based on the sort of the magnitude and the variability. So how consistent would each player deliver these things? So if it was a 2v2 over a half pitch, for example, then the variability in the data would be quite low, because basically, the players are exposed. They have to do a critical amount of work in order to complete the drill. For example, if they did a running drill, then the variability between players would be really, really low, because they're all doing some running-based work. But when it came to more match play and more tactically orientated games, the variability between players was very, very high. So then we could and then by characterising that over periods of time, we could turn around and say, well, these players haven't consistently been receiving a certain amount of training stress. Well, these players have. Or if we're going through a period of time or a phase where we think the physical demand, putting a high physical demand on the players is important, we should try and stay where possible away from these more tactically orientated drills, because then, because the physical loading, that some players won't get exposed to the physical loading, or some might get overloaded. And then, I went down a bit of a route of going, well, actually, we know what a high demand aerobic interval session might look like. For example, it might be 6 to 10 blocks of 4 minutes on, 2 to 3 minutes off. And we know what a hard hockey drill looks like, which will give us those type of, that kind of cardiovascular response that we're looking for. So let's do 6 to 10 blocks, 4 minutes on, 2 minutes off for this game. But because the variability in the data was large, and because the data and the sort of the variability between athletes was large, and it didn't really work because of that reason, and also it didn't actually meet the tactical requirements or the technical requirements of the coaches, because it was kind of, okay, we're only going to play this drill for 4 minutes, or we're only going to do this for 6 minutes, and sometimes you just need to let the game flow, or sometimes you miss, by being so prescriptive, you miss the sort of iterative process that the coaches have built up an enormous amount of sort of tacit understanding of what it takes to develop a team, and the journey and the direction that they're taking, and there's a large amount of feel to it which has got to be respected. And just because we can't characterise or quantify that doesn't mean it's not important. So by me saying we're going to do 6 blocks of 4 minutes today, and we're going to do 8 blocks of 4 minutes next week, it looked really good on paper as a sort of physical stress, but from a perspective of developing a hockey team, then it was irrelevant. So the place because we were constraining the coaches too much. So the place where we've got to now is essentially what we've got is we've characterised the sort of high-speed running demand, the cardiovascular demand, and the deceleration and acceleration demand of all the different types of drills that we do. So, and whether they're tactically orientated or technically orientated. So we've got this kind of classification of sort of high, moderate, low, and then also what happens when you manipulate area per player, so the pitch dimensions and the number of players within there, and then also what happens when you manipulate the amount of time they're working compared to where they're resting. And then what we can essentially say is we can give the coaches broad or general rules. So what I will say to the coaches this week, for example, is we're putting the players through, I'd like to put the players through a high training demand week. So therefore, if you're doing some 11v11 work, then keep the pitches big, or you can either do 10v10 or 9v9 over a full pitch. Then from that perspective, keep the rest periods really, really short between blocks. And rather than we play in 4:15s, why not play 4:20s? So therefore we really are getting that overload. We're in a really low demand week. We might say something like, okay, can we play over 3/4 pitch? Can we try and make the rest periods much longer, so the session density lower? Potentially can we make the pitch a bit narrower as well? So therefore, the coaches, regardless of the coaches, have got some constraints to work with, but what it means is they're really free to work on whatever it is that they need to work on to develop the team. So hopefully that's clear there.
No, absolutely. So you mentioned accels and decels and high speed running. Is there any? And I almost kind of cringe when I ask these kind of questions. But what other metrics are you looking at, which gives you what you're looking for?
Well, you know, it's funny actually. We've looked at, like, I'm sure as everybody's done, they've looked at those traces and they've looked at the different zones and they've got mental on it and looked at so many different things. Again, the starting point I had was, and the reason why we started to use GPS and training to start with was coming back from that question: how can we develop the players physically just through playing hockey? So therefore, I wanted to have an understanding. It's like, well, the next question from that is, what potential physical overload can you get from playing hockey? And you might get an overload from a cardiovascular perspective. So therefore, the first metric we looked at was time above 90% of max heart rate, and time above 80% max heart rate. So we can characterize the sort of total amount of cardiovascular stress taking place. The next metric we then looked at was based on, you know, the theory that if you spend more time above your maximum aerobic speed, you're going to be developing your efficiency, your kind of mechanical efficiency, and you're stressing the metabolic system to help deliver energy aerobically. And also we know that everything above your max aerobic speed has got an exponentially increasing cost. So therefore, how much distance or how much time do players spend on a session by session, drill by drill, week by week basis above their individual maximum aerobic speeds? And then same again from what other types of overload can achieve. They'll be undertaking repeated sprints, and they'll obviously be decelerating a lot. So so again, above or below. We got them to do a sprint, and we got some through speed testing and through like an agility based test, like a 505 type thing. We worked out what their maximum acceleration was and their maximum deceleration was, and how much time do they spend over. It was very arbitrary, 50% and 80% of that. So we get an idea of the kind of stress, or how many times they go or encroach above that. So we can have an understanding of how many times they're getting a stimulus which might improve their capability to accelerate or decelerate. So that was kind of starting position. The GP sport units we had was, and I didn't really trust or believe in the software that we had. If I'm sorry, I don't know. But and I think that all the different, and that's not being discreditory towards GP sport, but I think that's all the different softwares that are out there. There's an element of, with all of them, that there's a black box. And I couldn't work out how some of the numbers were created. So I went and built thankfully for my biomechanics PhD days, I'd spent a lot of time on Excel. So I was able to, and sort of force traces and stuff. So I was able to build a little thing on Excel, which allowed me to capture the raw data, filter it appropriately, and downsample the data to try get a better reading of a cleaner trace from the velocity component, and therefore allowing us to get a cleaner acceleration trace, so that we could be more confident in the acceleration and deceleration data that we were getting. So those were the starting points for the metrics. Obviously, things have moved on a little bit now. We're now not just interested in, can we develop the players physically through hockey, because we can to some extent, but we, from a tactical, conditioning and a specificity perspective, whatever that might mean, we can, we can certainly deliver that. But for tactical specific conditioning, we can certainly deliver that. But are we really going to get any overload to really develop players, their capability to perform repeated high intensity actions through hockey? Maybe not. So now it's more about understanding load, and trying to manipulate load on and sort of training demand in exactly the way that we were discussing just before. So therefore we look at things, we do look at the individual, so data relative to the individual maximum, but we also look at things on threshold basis as well. Like, critically we need to get up and down the pitch, and we want to try and beat our opponents at doing that, then there has to be it doesn't matter if you're going above, if you're well above your maximum, your threshold or not. Sometimes you just got to go and run at a certain speed, regardless of where your individual threshold is. So that's why we've gone towards not they're called, not individualized, but the other type of thresholds there. So and that's like, say, for accelerations, decelerations, high speed running capability, high speed running, and cardiovascular. So that's where we've got to, and we've actually started to look at repeated high intensity efforts as well now. So when we get a cluster of more than 3 of those actions within a 30-second period, we've started to look at those and build up a bit of a, and I found that really, really interesting. That is with the Catapult software, because we can then start asking the players questions, or asking the coaches questions as well. Like, when you say that you fatigue during a match, is it after you've made the first sprint, or is it after, is it because when you've made a few short clusters of sprints, you made 3, 4, 5 sprints, is it towards the 4th or 5th one that you get fatigue? Or actually, no, you can deliver that really, really well, but it's when those clusters start to pack up on each other, and as the game goes on, that's when you start to fatigue. And you can ask the coach that question, you can ask the athlete that question, and then you get an idea, or you get a sense from them about, are they kind of limited by their capability of their buffering capability, or is it or their ability to tolerate the lactate that will accumulate from those repeated high intensity efforts, which I think is different to repeated sprint ability. Or is it that you fatigue because your aerobic conditioning isn't appropriate to allow you to sustain and repeat these sort of chunks of work? That it's allowed us to provide a different insight into the conversations we have with our athletes and our coaches.
I mean, you mentioned there about kind of questioning, questioning the data that you've been provided. Do you think there's almost an acceptance that when you purchase a bit of kit, whether it's a Gym Aware, Push Band, Catapult, GP Sports, whatever it may be, that is giving you the data that you want and think? Do you think there's that acceptance out there without actually questioning what you've been given, what assumptions you're making off this bit of kit that you've bought?
Yeah, and I think it's one of those, particularly when you're in the field as well. Like, you just hope that the piece of kit you've been sold are reliable and valid, and it's a bit of a ball ache to go and sort it out if it's not. There isn't assumptions out there, and they're kind of based on the marketing from these products. You think that there should be, but equally, for me, actually, it's not about saying I can't use this piece of equipment, or I can't use this piece of kit because it's not accurate. It's about understanding the error. So when I'm looking at pieces of equipment I use, or technology I use, what I want to try and do is just understand the error. So what's the magnitude of the error? Where does it come from? Because ultimately that's going to be the thing which drives the interpretation. And those are the conversations I'm having with, like I spoke to you about Megan and Tom. Let's try and really understand what our error is within these systems. And then when we're interpreting data and feeding it back to our coaches and athletes, we can say, actually, this is a difference and this isn't a difference, although it might look like one. And I think that's what's important. So I would sort of suggest my suggestion for people who are just maybe not used these types of equipment before is to just try and understand the error associated with them. And there's some really, really easy ways of doing that. And once you do that, you can be really confident in what numbers come out, or at least the range of the numbers that come out.
So you mentioned it there. How would you go about assessing that error?
Yes, so I'll take the GPS.
Not to put you on the spot.
Yeah, exactly. Take the GPS units for a bit of a drive, and calculate the variability between the distance travelled and the velocities that you capture within them. Or I know, so you look at stuff that Martin Bouchard's done, where he stuck them all in he stuck them all in a crate and took them on a pulley around the football pitch. I think that would be the kind of easiest way of doing it. You can either take the units on a bit of a drive around the car park with you around the known distance, or you could, like say, take them all in a box and take them for a bit of a walk across a known distance and see what comes back. And then what you've got an idea of is if what's the variability in the distance travelled when you know that you've done a kilometre. What's the variability in that, and then you can work out kind of a coefficient of variation, and then sort of very, very simply, you've got an idea of when you're reporting things back, and if there's a sort of, let's say for example, our coefficient of variation is sort of 6%, and there's a 7% difference between players, and you can say, well, that is actually a meaningful difference. Whereas if it's the variability in the data is between sets is 12%, then you can say that 6% data, sorry, that 7% difference isn't meaningful. And you can do that with the like say, you can use a Smith machine for the velocity encoders, for example, and just they're all on there at the same time, going up and down at a known rate. Those would be the kind of some of the just simple little experiments that you can do with really simple statistics, just to help you gain insight. And I think it's important that the experiments are simple, and I think that it's important that the statistical methods are simple as well, because ultimately this is about collecting or characterising information to help inform practice, and not to be published in a scientific journal. Although there is an argument for saying that actually, if the data that you're feeding back is that important, then it should have undergone a similar scientific rigour to that published in an academic journal. But the debate goes on, Rob.
Yeah, I mean, excuse me. I just want to just move on to something. Well, the topic that you presented with Jonas back end of last year. So you discussed change direction. And you mentioned that you weren't an expert, but it came across well to me. But just want to discuss firstly your view of the determinants of change direction speed and how you may go about assessing it.
Yeah, so I think really, really simply from change of direction speed perspective, and again, are we talking about change of direction? Or are we talking about my sort of mindset or paradigm in my head on change of direction is shifted fairly fundamentally, and I'm starting to do quite a lot of reading into neuroscience and the sort of anatomy of the optic nerve going into the motor cortex and stuff like that, because I've really feel, and this is working with our current coach at the moment, that the perception action cycle is kind of critical to agility and, if you want to call it change of direction performance. You can't separate the action away from the perception, or equally the perception away from the actions that the athlete's undertaking. And I think from a purely mechanical perspective, your ability to change direction is going to be critically determined by your capability to kill your momentum and then produce momentum in a different direction. So fundamentally, it's about being able to absorb the momentum as fast and as efficiently as possible that you've got going into a certain direction change, and then being able to produce it in a different direction. So those are my kind of those kind of my two key principles of kill momentum and then produce it, which kind of sounds quite simple, but I think the way you do it, and some of the studies that are out there, and I might have to get this PowerPoint up there so I can remember which studies these are now, but that talk about the ability actually when you're changing direction, it's about being able to lower you can more effectively kill your momentum by lowering your center of mass by lowering your center of mass, by having a little bit more knee and hip flexion, and by trying to put your center of mass towards the direction of travel you're going to next. And then when you're actually making that change of direction, it's about making sure that your center of pressure is outside of your center of mass, and again your center of mass in the direction of travel, and then you're producing force very, very rapidly. And if you're making a sprint, and there's obviously getting into your kind of acceleration position. And I think the perception action cycle becomes so vital within this, because there's like loads of evidence out there as well that your kind of neuromechanics change when you're responding to a visual stimulus, and particularly a task or sport specific visual stimulus. There is large-scale neuromechanical changes or neuromechanical differences between somebody who's making a change of direction in offense versus defense, although the change of direction, the cut, for example, is exactly the same type of change of direction. So, for example, people who are defenders will typically have a larger braking impulse during their penultimate step than people who are attacking. So essentially, defending causes greater mechanical stress to your body, and you have to be stronger to be a defender. Versus an attacker, they'll have a greater propulsive impulse than the defender will do. So, and that allows them to be able to move their center of mass faster. So, from a training and from a training perspective, that means we've really got to make sure that these people that the athletes that we're training. It's kind of critical that if you, particularly a defensive change of direction, they're capable of recognizing the appropriate visual cues that allows them to orientate their body segments into a place where they can absorb their momentum or kill the momentum and produce a large braking impulse as quickly as possible, and then to be able to reorientate their body in the direction of travel. So I think those are kind of, for me, the other, there's some great work out there by Ben Serpel as well, and who was talking about the co-contractions that take place which modulate vertical stiffness. So that's particularly important when you're trying to make a change direction. Once you've killed your momentum, you're actually trying to go off in a different direction. And essentially what we've seen as well from say some of the Zebis work as well, that there's a hamstring firing latency when an unpredicted change of direction task. And what Ben Serpel's research has shown is there's some very, very clear co-contraction strategies which take place around the ankle and the knee joints when you change direction. And if we know that those kind of co-contractions take place, there's a latency which takes place, and they could be latent in response to a visual stimulus. Then essentially what we need to try and do is get people to fire their muscles harder than harder and earlier. And so we can do that by using visual stimulus and context specific visual stimulus to make sure people are firing their muscles far harder and earlier, and that will allow them to orientate their body segments in the right position and to be sort of effective at their task completion. I don't know whether I've waffled on a little bit there or just...
No, that's fine, mate. No. No. What I was going to say next is, how have you integrated them thoughts into an assessment of some kind?
Yeah, definitely. So I think if we take the two basic principles of it are sort of killing momentum from a pure physical perspective, killing momentum and producing momentum. Then what I want to try and do is find a couple of field-based assessments which allow me to understand how effective our players are at absorbing momentum versus producing it. So the way that I think that you could definitely look at that is a depth jump off increasing depth heights, a single leg depth jump over increasing depth heights. That's not a drop jump where we're looking for a limited contact time and we're looking for sort of stiff low limb joints and a nice high RSI. The jump I'm describing is one where you land in a counter movement position and then you jump from there. So you land off a box, 20, 40, 60 centimeters in a counter movement position. You jump from there, and that's a real nice field-based assessment to be able to determine how effectively people can kill their momentum. Which essentially, as the box height increases, what you've then got is an increase in momentum when they hit the floor, because their velocity will be higher and their mass remains the same. And then you can have a look at how, if you're fortunate enough to have a force plate, you can have a look at things like contact times the sort of absorption duration of the counter movement from that period. And if not, you've just got your contact map. You can have a look at your contact time and your flight time. So I think another way of doing that would be with a single leg counter movement jump with increasing barbell load. and you've got your linear encoder on that, you've got your velocity, your gym aware on that, for example, and you can determine, again, there's an increase in momentum because on the way down, there's more mass on the way down. Excuse me. The only challenge with that though is that you're not particularly controlling momentum because you could just take the weight down slower. So that might not be a very, very good determinant of the ability to kill momentum compared to the increase in height depth jump. And I would use an increase in height drop jump, single leg drop jump, as a way of characterizing the ability to produce momentum or change to be able to produce force going in a different direction. For kind of exactly the same reasons, larger momentum challenges, and there's an increase in stiffness demand as the boxes get higher. So then you can really use that information to determine have the players got the structural or physical qualities to be able to perform or produce these tasks that you're asking them to do in a competitive environment, which I think is really critical.
Mm-hmm. So all them ones there that you've mentioned are all single leg?
Yeah.
Why would you prefer that over a bilateral assessment?
That's a good question. I think you could definitely jump in. Maybe I'm just being soft now. Yeah, do double it. Yeah, you could. You certainly do bilateral as well. But I think that when we look at our change direction tasks, that people tend to have to absorb most of their energy or kill most of their momentum. I keep saying kill momentum. I hope people know what I mean by that. But absorb most of their energy in preparation to change direction on single leg, whether that is landing, whether that is coming from a cut, from a turn, whether it's going into a high jump, which is a kind of really aggressive change of direction as well. These things tend to take place, or the critical instances tend to take place on one leg. So you tend to absorb or kill your momentum predominantly on one leg, and then produce it in produce a direction change off the other one, which is why I think the single leg's quite important.
Cool. So just moving on again to the kind of focus of your chat before Christmas, which was looking at the constraints-led approach. So just want to describe to us what that is and why you think it's important to tick the boxes that you and your coaches want to tick to get them better get your players better at hockey.
Yeah, for sure. I think so. The constraints-led approach, for those who aren't familiar, it's developed. It's dynamic systems theory. It's developed by many people, but Carl Newell was probably the foremost founder of the work. And essentially, the kind of the theory is of dynamic systems theory is that what you're always trying to do is complete a motor task. You're trying to complete a motor action. The intention is to complete a motor task. Now, the mechanics that you use to produce that motor task or to achieve the motor task will emerge based on the constraints of the environment, the task itself, and the athlete. So let's say, for example, the intention is, or what you're trying to achieve is jumping in the air to catch a ball. Now this is bad. I haven't actually used this example before, so I don't know where it's going to. So jumping in the air to catch a ball. Now let's say, for example, the task is you're jumping up in the air, and and suddenly someone's giving you a nudge in the air. You're a football goalkeeper, and you're in training, and you're just taking the ball, and there's no one there. And then suddenly the task changes ever so slightly because now you're in a match. You're still trying to take that cross. You're trying to jump as high as you possibly can. But then you've got two steaming centre forwards smashing you, and you're trying to take the ball in that. So the task demand has changed ever so slightly, and therefore the mechanics that you've used or that have emerged in order to allow you to jump to take the ball in that training-based environment will have to be different to that competitive scenario where you might require a little bit more trunk stiffness. You might have to jump with a bit more aggression, a little bit more momentum, and your knee might need to be higher to get one of them out of the way. So mechanics emerge based on constraints, and similar from a environmental perspective, it might be a little bit windy, or the ground might be wet, and therefore that's going to alter the mechanics that emerge. And you might be fatigued, or for example, we might have done some training and you've got a lot, and we've improved your power, which might mean you can take the ball, you can move off a little bit later, you can take the ball a little bit higher in the air. And that's the important thing from the perception action cycle, that people just think it's perception leads to action, but actually how you perceive a task demand will be determined by your action capability as well. So if you could jump, if a ball's sort of 5 meters in the air, you're not going to jump to get it because you don't feel that you've got the physical capability to go and deliver it. So your perception and is determined by your action capability. So it's a cycle. Whereas if it's 2 meters in the air, you might back yourself for it, and therefore, therefore the action that you take is determined by not just the perception, but also your perception of your physical capabilities as well. So, long story short, I've rambled again. Please excuse me. That your mechanics emerge based on the task that you want to try to complete, and the constraints of the environment, the athlete, and the task itself. What that means from a training perspective is, particularly if what I want to try and do is, if we said, for example, we go back to the killing momentum, for example, and how I perceive that to be really critical in improving people's ability to change direction. How quickly and effectively can you kill your momentum? Now, so it's not good enough for the athletes that I work with to be able to do that in that scenario where I'm on the track with them and I'm telling them to stop dead on the line, or we're doing a nice neat drill, they've got to sprint to the cone and sprint back. They've got to be able to do that in hockey-specific tasks, in context-related tasks. I'm not just like, with that doesn't just mean stick and ball hand. We've got to make that related to what's important, and that's winning the ball or eliminating somebody. So it's not good enough just to be saying, I want to make you more agile, or I want to make you, the task has got to be, we've got to orientate our drills around winning the ball. And so what I try and do is the constraints of the task or the environment or the athlete to try and get them into a position where we're forcing appropriate mechanics, but they're still trying to win the ball. So that could be an example where a player is, we've got a 1v1 scenario. It'd be difficult for me to describe this without drawing it out. We've got a 1v1 scenario. One player is the attacker, one is the defender. They're 10 meters away from each other, facing each other. The attacker has got the ball and starts to go. The defender sprints up as fast as he possibly can, and what I've done is I've put a cone, or I've put a mini hurdle sort of 5 meters away from the attacker. Okay, so at the point when the attacker and the defender are most likely to meet, the defender has got to get, before they are allowed to sprint and chase the attacker down, they've got to get themselves over their cone. And what I will say to them, the one constraint on it is you've got to land, if they're going to the right of you, you've got to land on your right leg over that hurdle before you're allowed to sprint. And if they're landing to the left of you, you've got to land on that left side before you change direction and go. So that means that both players are sprinting full tilt. The defender, is going to have to make a change direction. What it's forcing them to do is, because it's so fast and it's so competitive and they want to get off and win the task, it's forcing them to absorb as much energy as possible off that inside leg before they sprint off. So we're forcing appropriate mechanics in a context-specific scenario. Does that kind of make sense?
No, absolutely. Would
No, it doesn't.
No, it does. No, it does, mate. Would you ever do that in a situation that doesn't have hockey-specific actions? So there's no defender, there's no, they haven't got a stick in the hand. Would you ever do something that's purely physical?
Yeah, for sure. The way we're orientating our training at the moment is we're doing sort of pure physical and then into hockey, or, that could be into all different types of sports, so physical hockey. I think the important thing to remember is it's important we don't get away from this, that, one of the constraints on an athlete's capability to perform a task is the athlete themselves. So if they don't have if they don't have an appropriate motor strategy to change direction, if it's risky, for example, if every time they change direction their knee dives into valgus, or they don't get any range through their knee and hip and it all comes through their spine, or their ankle's unstable, then that's something that we've got to change, because that, again, the constraint, the thing that's constraining the task is the athlete themselves. So there'll certainly be scenarios where you're kind of teaching them how to move, or you're improving their physical capability to absorb momentum throughout their lower limb. So I don't think these things don't certainly happen in isolation. And what I'm definitely not saying is that we should throw traditional S&C away. We still need to get our athletes strong, because ultimately what that means is that they've had a change in their capabilities. Therefore, they're more capable of, or they're less constrained by themselves when they need to try and achieve a task.
Mm-hmm. How would that approach change, or would that approach change with younger athletes, less experienced athletes?
No, I don't think. For me, it wouldn't. I think the idea being that we're still trying to develop fundamental physical capabilities, because we understand that there's physical capabilities which limit our athletes' ability to perform tasks. We're still trying to, and what we're also trying to do is develop some of the perception action cycle, which is so critical to sport performance. I think there's some generic perception action cycles, like like for example, interception. I think space management, manipulation of your body in relation to another opponent's body. These are kind of across lots of different sports. Space, time and distance management, and all of the fundamental athletic skills, like being able to stand on one leg and balance, being able to hip hinge, being able to squat on one leg or bilaterally with appropriate mechanics, being able to resist rotational forces through your trunk and your junk, and push and pull appropriately. These are all fun, because if an athlete doesn't have these motor tasks or these motor skills available to them, then they simply won't be able to complete the tasks that you're asking them to do, which involve a perceptual element as well. So I think that I don't think it diverges too far away from the traditional long-term athletic development model. But hopefully what it does is adds in some context.
Mm-hmm. Cool. Well, I'm just conscious of time, mate, because I don't want to keep you all night. You've got some Excel to do. You've got to get Excel, mate, and data to crunch and stuff, no doubt, on a Sunday night. But
it's all right.
I just want to thank you for your time, first of all. But just before I let you go, where can people keep in touch with what you've got going on?
I'm on Twitter. I love a bit of Twitter. I like a tweet. I love a retweet. I think it's let me just check. I think it's at Ben _Rosenblatt. At Ben, let me check. I think it's at Ben _Rosenblatt. And if people want to get in touch or speak directly, then just hit me up on Twitter, and I'll send you my email address or phone number, and we can have a chat. More than happy to stay in touch.
Any more speaking engagements on the horizon?
Yeah, I think there's a few coming up, actually. We get back in. Yeah, there's a few. I'm doing the football science and medicine one, which I'm really looking forward to.
So when's that? Where's that?
That is. Oh, you've killed me here.
Sorry, mate.
I'm looking everything now. Oh no, and it's taken ages to open up. Can't quite. I think it's in May.
It's all right. All right, okay. Is it the one at St George's Park?
That's the one at St George's Park.
Yeah. Okay. Yeah.
So I'll be talking there, and I'm looking forward to doing that one, because that's speaking to John Goodman. Basically, the topic is, if I worked again in football, I would. So that's nice. I'm really excited to present on that one, even though I can't remember when it is.
It's normally in the summer. It's normally the off season, won't it be May or June or something?
Yeah, exactly.
Yeah. So did you say you're speaking anywhere else? Science and football and...
I can't remember. You've absolutely stumped me there. You've killed me there.
It's all right. It's all right.
I've got a few things cut out.
No worries. Well,
my team at the moment.
That's fine, mate. Don't worry about it. No doubt people will. You'll tweet. You'll tweet. Put it on Twitter and then retweet it. So
yeah, exactly. I can't see anyone coming to a conference just to listen to me. So
You're humble, too humble. So yeah, I really appreciate your time. Giving up 50 minutes on a Sunday night. So,
mate, it's a pleasure to talk to you. It's a real honour to be invited to be on this. So thank you.
No, pleasure, absolutely pleasure. But I'll let you go, and we'll keep in touch.
Nice one. Cheers,
all right,
Rob.
pal. Thanks, mate.
Thank you, mate.
Bye. Thanks for tuning in to episode 70 of the Pacey Performance Podcast. Hope you enjoyed the chat with Ben. Just before I let you go, if you are interested in the Pacey Performance webinar series, episode 3 with Matt Jordan, if you go over to paceyperformance.co.uk/Matt, all of the information is over there. Also, if you want to check out any previous episodes of the podcast, you can go to paceyperformance.co.uk/podcast. So thanks for tuning in, and I will speak to you in episode 71.